All right, law of tangents is where we're at today.
Like it says, truth, this really isn't a very necessary law. Oh, I made changes yesterday, but then I forgot to save them. It's supposed to be fraction bars there. I don't know why the fraction bars are not coming out in my formulas, but they aren't. I'm not going to even think about proving this law to you. It's not the world's most useful situation. It's just something that we can work with. Notice I know two sides and two angles for this, or at least I know two sides, and maybe the sum of some angles or the difference of some angles. But it's a proportion. It's a minus b over a plus b equals tangent 1/2 of angle A minus angle B over tangent 1/2 angle A plus B. We can, of course, do the reciprocal of this. It's fine, but you'll notice that the minuses are on top together, the pluses are on bottom together, or vice versa. Tangent of half of that sum or half of the difference, not half the tangent. It's half the sum or half the difference. We, of course, could repeat this with BC, BC, or AC, AC. It's the same formula. There's almost nothing that can be done with law of tangents that can't be done with law of sines and law of cosines. So as far as its overall usefulness goes, it's very, very, very small. Yet it is still one of those laws that we deal with and come up with. And the key to working with it is the idea of it being a proportion. I mean, it's A over B equals C over D. Standard old proportion. How do we handle that? We often cross multiply, don't we? That's how we solve these things, when we have a proportion. So for some people who love proportions and love proportional thinking, this is a formula they love because it's proportion. We can work with it that way. But that's the way it is. Usually we don't choose this because law of cosines is more applicable when we have that. And again, we only use it when we have two sides and an included angle. So kind of a similar situation to law of cosines. Law of cosines is almost always easier, I think. But nonetheless, we do have it. So let's see how it works. And again, all my fraction bars seem to disappear. So these are a little darker. All right, and the 1/2. Just putting these back in. All right, so if I have two sides, side A and side B, and angle C is 48 degrees. Now again, normally we'd probably attract that with law of cosines, two sides and an included angle. But the problem says we must use law of tangents, so we must. Here's the way it works. We simply substitute our values. I know the A plus B and the A minus B. I can do that pretty easily. All right? Angle C is 48. So if I know angle C is 48, what is the sum of angle A and B? I don't know A or B individually, but I know their sum must be where do I get what? Oh, I haven't gotten that far yet. I'm still up here. Okay. If angle C is 48 degrees, then A plus B has to be 42 would be if it added up to 90. What do triangles add up to? 180. There we go. So 132, because again, the other two angles must add up to 180. You must give me a sum of 180. All right? So I start my formula. I fill in my values. A, B, A, B. A plus B I know is 132. A minus B is my unknown. All right? In this case. So 71 minus 27 is 44. 71 plus 27 is 98. So that's where those values come from. Tan 1/2 A minus B is still unknown, and half of 132 is 66. Because take tangent of half the angle. I did start the recording, didn't I? Did I start the recording? I did? Yeah, I did. Okay, good. Just making sure. Just kind of had that feeling all of a sudden. It's like, did I actually do that? So I multiply, kind of do the cross multiplying thing, but I'm only going to multiply this denominator in for now. I'm not going to do a full cross multiply because I just wind up dividing by 98 again anyway. So I multiply the 44 tan 66 divided by 98, and then I get 1.0084 as tangent of 1/2 a minus b. So far not so bad. I mean, it's a little tedious, but it's just plugging the numbers in and kind of cranking things out. But here's where things get a little tricky. We aren't done yet. I have tangent of 1/2 a minus b, so I take the tangent inverse of both sides. When I do that, I still have 1/2 a minus b as the tan inverse of that. So I take the tan inverse of this angle, and I get 45.24 degrees is 1/2 a minus b. I actually have to multiply both sides by 2 to cancel the 1/2. And I get 90.48 equals a minus b. I still don't know a or b, do I? I just now know the difference, a minus b, don't I? So a minus b equals 90.48. What do? Well, we remember that a plus b we knew was 132. We got that. That was our very first step, wasn't it? A plus b is 132. Well, lo and behold, if I know a minus b and a plus b, I can set up a system of equations, add the two equations, and I get 2a equals, when I add them, that's not 42.48. What in the world did I do there? Oh. That's interesting. 2a would be 222.48. Which, if we rotate that back between 0 and 180, would be 42.48, right? But a would be 111.24. I don't know why I did 42.48 there. I don't know why I rotated it back in. I don't know why I did that. Okay, so anyway, so there we are. So I found angle A is 111.24. At that point, I can find angle B pretty quickly by doing the A plus B, A minus B thing. It's pretty, yeah.
I have no idea what you just did with that, like, 2A thing.
Oh, I just added the equations. A plus A is 2A, B minus B cancels out. Just the old algebra 1 thing. And then, yeah, I don't know why 42 is there. Oh, I subtracted instead of added. That's what I did. If I take that and subtract, I get the 40. That's weird. Why would I do that? I don't know. Okay. So there we are. That's the method. Now, this or law of cosines. Which one would you normally choose? Obviously, law of cosines is way, way easier way of handling this problem, isn't it? And for the most part, I'm not going to make you do a lot of this law of tangent stuff. This is going to be much more the exception rather than the rule. But it is a method that we do want to expose ourselves to. It only appears once as a mandatory problem on your tests. A law of cosines is much easier and quicker, but let's practice another one. Okay? A is 27, B is 15, and measure angle C is 104. So measure of angle A plus B has to be 76 degrees. So setting up my formula, I'm going to do A minus B over A plus B is tangent of 1/2 A minus B over tangent of 1/2 A plus B. Now, you're probably wondering, why am I setting it up with the minuses on top and the pluses on bottom? Why not the other way around? Because my unknown is going to be angle A minus angle B. I know this, I know this, I know this. I want my unknown in the numerator because it just makes my life easier to have my unknown in the numerator. It saves me a little work later on. Substituting the values, A minus B would be 12. A plus B is 42. Is tangent 1/2 A minus B over tangent half of 76 is A plus B is 76. Half of 76 is 38. So 12 tan 38 over 42 is the tangent of 1/2 A minus B. Twelve tan 38 divided by 42. Oh, I'm in stat mode on this one. Never mind. 12 tan 38 divided by 42 is 0.2232. Okay, so we take the tangent inverse of both sides. So tan inverse of 0.2232 is about 12.6 degrees. So multiplying both sides by 2, that's 25.2 equals A minus B. Now that we've got that, now that we've got that, we bring down our fact that A plus B is 76. When I add the equations, I get 2A equals 101.2. So divide by 2, 50.6. Yes, 50.6. All right, now I know angle A is 50.6. A plus B is 76, so B must be 25.4. Because A plus B has to equal 76. A minus B has to be 25.2. Yep, sure enough, that works out. Yeah? Add 25 plus 76, 25.2 plus 76. No, 25.2. Yeah, that's okay. All right. So, I mean, it's not like it's impossible. It's not that terrible. It's just that it's not convenient. That's my biggest problem with law of cosines, or law of tangents, excuse me, is that it really is not that convenient. We can work it a little differently also. I could give you something on the lines of, I'd give you the two angles. Say angle A is 47. Angle B is 29. And A plus B, the two sides, is 49. All right? Now, this seems to me even a more kind of contrived situation, because there are very few instances I can think of where I'm going to know the sum of two sides of the triangle and both opposite angles and not anything about the third side. I don't know the individual sides. I don't know what A is. I don't know what B is, but I know their sum. Okay, that's kind of a weird created situation just so we can apply law of tangents, isn't it? But it does exist in the homework. It could show up on a quiz. And honestly, this is almost a little bit simpler because when I set up, the a minus b is what's unknown over a plus b, which is 49, is the tangent of 1/2 a minus b on top again. 47 minus 29 would be 18 over the tangent of 1/2 of a plus b, which would be 76. So that's tangent of 9 over tangent of 38 equals a minus b over 49. So a little easier, actually. We just have to remember it's tangent half the angle, not half the tangent. So 49, a minus b is 49 tan 9 over tan 38. So actually, this is a little quicker. 49 tan 9 divided by tan 38. I get 9.93. Saying, okay, now what? Well, it's fine. I have a plus b equals 49. A minus b equals 9.93. If I add them together, I get 2a equals 58.93. So 58.93 divided by 2. 29.465. Okay. So B is going to be 19.535. Or about 29.5 and about 19.5, probably to the nearest tenth would be fine. So there's A and B. So actually, this contrived situation is a little quicker. And actually, the only way we could possibly solve this problem, given this information, law of sines and law of cosines is not an option in that situation, because we're actually given the sum of two sides but not the measure of either individual side. The thing is, from here we would have to use law of cosines or something to still define C and finish solving the triangle. Actually, we could get angle C, I guess, pretty easily. We could use law of sines as well, because angle C would be easy to find. It's not ambiguous, at least. One thing I can say about law of tangents, it does not give us an ambiguous case, does it? Yay! It's not ambiguous. All right. So anyway, your assignment does deal with law of tangents today and practicing this. Again, it's not that it's hard, it's just that usually there's an easier way to do it. But here we are, November 5th. So 4/8, 12 through 20 even. Let me see if I want to keep that. 4, 8, 12, 14, 16, 18, 20. Actually, I'm going to make your life a little easier. 12, 16, 20. So instead of all evens, just every other multiples of 4. 4 through 20 multiples of 4, and then 23 and 24. So I cut a couple of them out there so it doesn't get too repetitive. All right? I want you to practice it, but I don't want to pound it into the ground on it with you. Tomorrow we'll be reviewing. Quiz on Thursday. Then we get to move on to the second half of the chapter. And second half of the chapter deals with finding areas of triangles, which is actually not bad at all. The last section, we always seem to throw that one section there. It's a little bit fun, and that's where we start dealing with vectors and navigation again, but this time with oblique triangles instead of just with right triangles. So the vector section is always a little bit challenging. You might want to be looking ahead to that. The areas of triangles stuff is pretty easy, actually. There's 2 or 3 formulas we have to learn, and you just plug and crank numbers through it. They're pretty simple. The biggest challenge of Chapter 4 is we have several formulas you have to have memorized. Law of sines, law of cosines. Comes to law of tangents, I may actually plop that one on the board for you. I'm not worried about you memorizing that one. So, hand me that piece of chalk, Jaden, and I'll write that on the board right now so that nobody gets concerned about memorizing the law of tangents. There. They'll probably be up there for all time now. But I don't want you to worry about memorizing the law of tangents. I just want you to be able to use it. Fair enough?